All right, number 32. Suppose you're given, suppose a polynomial function of degree 4 with rational coefficients has the following zeros. Find the other zeros, or 0. So in part A, they say that there are 3 zeros given. So you have 3 zeros. But now it's degree 4, so there should be one more 0. There should be one more 0 to account for. So if you think about it, there would be 4 factors. If -1 is a 0, then x plus 1 is a factor. If the square root of 5 is a 0, then x minus square root of 5 is a 0, is a factor. If 14/5 is a 0 of this function, then x minus 14/5 would be a factor. Right? Like from number 31, we're talking about the same way. What value would give me a 0 inside these, these factors? Well, these values give you zeros inside these factors. So what's the last one? Well, there's a theory called the conjugate root theorem that basically says if you know that one of your zeros has a square root on it, then you automatically know that there's another 0 that would be the conjugate of that, which in this case would be a negative square root of 5. So if you know square root of 5 is a 0, then automatically negative square root of 5 is a 0. So you say x plus square root of 5 would be your other factor. So where would this? So how do you know this? Well, whenever you're solving these, a lot of times you'll find you'll come down to the end and you'll have to solve a quadratic to solve for these things. And when you solve a quadratic, use the quadratic formula. Remember, the quadratic formula has this plus or minus in it. So one answer has a positive, one answer has a negative. That's what this is talking about. If you have a square root or an I, i's work the same way. If you have an I, then you automatically know negative I is one of the zeros. Okay, so if they give you one of them, then you automatically know the other one. It's a conjugate of it, which is basically changing the sign on the square root. So like part B. Part B says that negative I is a 0 and 3 minus square root of 7 is a 0. Well, the conjugate to these would be positive I and 3 plus square root of 7. I don't change the sign on the 3. I just change it there on the 7. So the conjugate root theorem says that if you know one of those roots, then you automatically know the other one, which is pretty handy to know. What about part C? Well, 0 and negative 5 are just regular numbers, but that 3i tells me that negative 3i would be the other 0. And we only got 4 because each one of these has a degree of 4, so we're accounting for the fourth one. This is this third and fourth one. Part C, this would be the fourth one. Part D says that 5 plus 2i and 2 plus the square root of 5, they're both zeros. Well, the conjugate to that, you just change the number in front of the I or in front of the square root. You don't mess with the front one. Those would be the other two zeros, the conjugate roots. So number 32 is really easy if you know that little trick. Right? The little trick to this is that if you know that one of those roots is a square root, then you automatically know the negative of that, the positive of that. You flip it, or you flip it, make the conjugate of it.